recording. All right, everybody, I'd like to welcome y'all to the July meeting of the Excel Business Intelligence Virtual Chapter. Before we get started, we'll go through some slides about the PASS community. If you're on this presentation, you're probably a member of PASS. And what just happened was 24 hours of PASS the last 2 days. If you missed any of these sessions, you can go to that website and they'll be all recorded for you to watch later on. Also be aware that the summit is coming up. This is the big conference for the PASS community. It's October 31st through the 3rd. Actually, it starts on the 30th with pre-cons. I think they put the 31st because they have a social event on Tuesday night. But Monday and Tuesday is your pre-conference sessions. Your regular sessions are Wednesday through Friday. If you register before the 23rd, you'll save $400. If you want a promotional code, email us at excelbivc@pass.org, and I can give you the code for this virtual chapter for you to get a further discount. Also, the Business Analytics Conference is now a single day. The upcoming one is going to be in San Diego. There's 2 all-day sessions, one by Dean Abbott, another by Ann Legg. If you want a full day of business analytics training, you can go to that in San Diego. Also, the elections for the PASS Board of Directors is coming up. There's 3 seats open for the next term. If you're interested in running, there's the governance@pass.org to email. Also, be aware you'll get emails about voting, and it's very important to voice your vote on who's on our board of directors. And in the next probably month to 2 months, you'll see many emails about finding out who is running. Also, they're looking for people to volunteer. If you feel you want to volunteer for some part of PASS and you like some of these attributes or you express some of these attributes, go ahead and sign up to maybe even be one of the board of directors. There's also an award given to a community person that's an outstanding volunteer for the whole year. It'll be given away at the summit this year. But if you know somebody and you want to nominate them, please go nominate them. Virtual chapters, or they call them virtual groups now, happen almost every day of the week. You can go to the pass.org site to see all the ones scheduled. Ours is today, and there's a couple coming up in the next week or 2. There's many, many virtual chapters. Some of them are language specific. And of course, there's the free SQL Saturdays, which everybody's always excited about, on the 29th in my hometown of Baton Rouge. There are many of them. Go to SQLSaturday.com. You can actually get free training for a whole day on a Saturday. And of course, the membership to PASS is free. So please go to pass.org and be a part of this great community where you share, network, and learn a lot of information. Our speaker today is Gene. He's going to be talking about some design aspects of business intelligence, and I am going to go ahead and turn it over to him.
All right. So let me make sure I'm sharing the right screen. And there we go. All right. Does everything look good?
It looks good.
Fantastic. Well, let's get started. So I am really excited to be presenting to the Excel BI user group. I'm really excited to be able to talk about this topic for all of you. Now, I want to be clear that anytime that I use the phrase Power BI in this presentation, the exact same concepts apply to Power Pivot. From a database theory perspective, there's not a real important distinction. So even though there's a number of times where I'm going to say Power BI, just be aware that this applies to the exact same tooling if you're living in Excel and just using the Power Pivot add-in. All right. So let's get started. Quickly about me, I'm a business intelligence consultant for All Lines Technology. I've been doing that for about 5 years now. I'm a Pluralsight author. My first course just came out on Power BI data gateways. I'm really excited. I'm also a PASS Summit speaker, or at least I will be this year. So this has been just a crazy exciting year for me. I co-lead the Pittsburgh Power BI user group, and I am a former newbie. and probably still am in a lot of areas. But the reason I always put that last line in is I want to encourage each and every one of you to consider presenting, speaking, and giving back to the community. Because 5 years ago, I didn't know about this community at all, and I didn't know a lot of the stuff that I needed to do my job. 5 years ago, I was just out of college. I had taken maybe one course on databases, and that was about it. I could do my select stars, I could do my wheres, but I was trained on MySQL and Access. And whenever I got my current job, the job description was .NET/SQL developer. And I thought this is going to be great. This is 90% .NET, 10% SQL. I can do this. Well, it turned out that that was flipped. And in fact, it was 10% .NET and 90% SQL. And half of that was administration. So I had a lot of learning on the job that I had to do. And the thing was, at that time, I remember Googling furiously, what is a stored procedure? What is the difference between a view, a stored procedure, and a function? Because the work that I had done in MySQL didn't involve any of those. I don't even know if MySQL supported views at that time. It very well could have, but the point being, I learned on the job, and I've gotten to where I am now because I found out there was a local user group, and I went and attended. And then I found out there was a SQL Saturday, and I went and attended. And my mistake was I went to the after party. And I got cornered by Rick Hygas and Gina Walters, and they said, you should present. And I said, I've been doing this for a year, I'm not qualified. And they said, you should present anyway. And each and every one of you, Alan White loves to say, has something to teach us. So really, please, please consider presenting to your local user group, presenting to a group like this. They're always looking for speakers, and you all have something to teach us. So really give that some consideration. Okay, enough about me. Let's get to what you came to learn about. So we're going to talk about database theory. We're not going to be talking about anything crazy advanced. For a lot of you, this might just be a refresher. But the question is, why this talk? Why would I want to give this talk? And why focus it on Power BI? So Power BI and Power Pivot present a very unique challenge because self-service BI, by its nature, encourages ad hoc learning, right? Because if you are taking someone who is not per se a data professional, you're taking someone whose job is not to daily work with data, who is not classically trained in terms of databases, but instead you're taking Chris from accounting and saying, hey, I know you need these general ledger reports, or you're talking to Susan in sales and saying, hey, I know you need to see the commissions for your team. Here's Excel. Here's a connection to a data source. Have at it, right? That's self-service BI. And so it encourages more of that just-in-time learning. It encourages more of learning just enough to be able to do the job that needs done. And Power Pivot and Power BI definitely exacerbate this because they're designed by Microsoft to reach a broader audience. Microsoft very clearly has its bullseye aimed at the broader business community and are looking to be able to provide business intelligence capabilities without entirely depending on IT or development to provide those capabilities. And again, as I said, not everyone is formally trained. Even people who work with databases day in and day out, many of them came in from a lateral move. Maybe they were a sysadmin and they had to administer SQL Server and now they're doing queries. Or maybe they just never went to college at all, or at the very least didn't study about databases. That's true for a large number of people in our community. So as a result, I think it's important to maybe just take an hour and talk about some of the fundamentals with database theory. And the goal of this talk is to communicate in a way that's a little bit more applied. So we're still going to be pretty theoretical, pretty pie in the sky, but at least have some references to, okay, how does this relate to Power Pivot? How does this relate to Power BI? So, so that's the goal, is to make it so if you're coming more from the Excel side of things, you're at least going to have an idea of some of these terms that you might hear about, or a better idea of how important they are to be able to do your job. So what are some of the problems that we run into if you don't have a strong theoretical foundational background? One of them is duplicate rows, and this is often caused by bad joins. Now with Power BI, a lot of times it won't even let you do a bad join because of the way that it's structured. And we'll talk about that. But I've seen it dozens of times with the SQL world where you join two tables together and you didn't have a complete understanding of how the data was laid out or what it was supposed to be joined on, or it may not even be your fault. It may be that you have this archaeological dig of a legacy system and you have to go in and you have to guess. And many times you might be guessing based on names of columns and hoping for the best. And whenever those guesses are wrong, or whenever you have incorrect guesses about the level of granularity you're dealing with, which we'll talk about, you can have duplicate data. Another problem is just muddling through your modeling. If you understand what each of your tables represents, what the keys are, what the granularity is, what the cardinality is between those tables, it's much, much easier in an intuitive and structured way to start laying out your data model and working with it, as opposed to a situation where you really don't know, you don't have a concrete understanding of what those concepts mean, just more of a gut feel. And so you're forced to do joins and modeling based on guesses. You have two tables that have the word date there and you join them on that, or you have two that have location, but you find out there was another key you were supposed to use, that sort of thing. You can also run into the issue of aggregates not adding up properly, especially if you've got data that isn't properly normalized. So if you've got two different levels of granularity in your tables combined, like let's say we're going to see as an example, if you have your state data and your city data combined and you're trying to do aggregates on the city information, if you're trying to do aggregates on the state information where there's repeated values, you're going to have different results for your aggregates than you expected. So if your data is not clean or properly normalized to begin with, and you don't even know what that means, then your numbers could be totally off. And a lot of times in this world, we're not connecting, especially if you're coming from Excel, you are probably not necessarily connecting directly to the relational database. There is a good chance that you're dealing with an export from some report, some CSV file, some file dump, some nightly data dump, and normally you're pulling that into Excel. And a lot of times that kind of data is denormalized, which we're going to talk about what that means, but there's a risk of your aggregates being goofed up because you may not have some of these theoretical underpinnings. So let's talk about what's going to actually be in this presentation more specifically. So again, we're hitting some of the classics. We're not going into anything deep, not going to anything too fancy. If you look at this and you're like, I know all this stuff, I'm not going to be offended if you hop out. That being said, I'm hoping this might still be a good refresher, and maybe you learn a couple things about how these concepts apply more directly to Power BI and that sort of thing. So we're going to talk about keys. This is the fundamental starting point when you're talking about database theory, is a key. And there's a bunch of different types of keys, and we're going to talk about what they all mean. We're going to talk about joins for those keys. We're going to talk about normal form. So if you've worked with the data world, and more of the database side and less of the Excel side, you've probably heard of a phrase called normalization, and you've probably heard of something called normal form. And one of the challenges is that if you were classically trained, you learned about 3 different levels of normal form, and then you promptly forgot about them because you never actually needed to know those levels. And in truth, you're able to work on more of a gut level when dealing with this sort of thing, but it's still important to understand what they represent, because it's going to help you work your way around the data, especially whenever you need to change between different levels of normal form or to denormalize, which means to flatten out the data. So we're going to go into detail about that. We're going to talk about granularity and how different tables relating to the same data will have different levels of detail. We're going to talk about cardinality, which is just a fancy phrase for how the tables relate in terms of quantity. So a state is going to have many cities, but a city is only going to have one state. That kind of relationship. And if you don't have a good solid understanding of what that relationship is supposed to be, you can screw up your filters. You can try and do a join and it's not going to do it properly in Power BI. Or you could just have weird behavior with your data in general. And last, we're going to talk about OLTP versus OLAP, which are basically these unnecessary 4-letter acronyms for relational database design in your ERP solution and analytical design and more of a reporting-based solution. So again, we're hitting the classics, we're hitting the foundational stuff. Nothing too exciting, nothing too sexy, but again, I hope that for a lot of you who are sort of just-in-time learners, this is really helpful. And I'm hoping for those of you who have been more classically trained, this is going to be a nice refresher. So let's talk about what is a key. So in my mind, a key is simply a way of identifying a row, ideally uniquely. So it's a column or a field or whatever you want to refer to it as that you're going to be using to say, I want this row. Just like if you were to go to a library and you want to pull out a book, how do you identify that book? You know, you're either going to have that book number and, you know, the Dewey Decimal System, or maybe you're going to have the book name. And if that key isn't unique, it can be problematic because let's say you're looking for some sort of book, we'll make up one called the Alpha One. And let's say that was a popular name and there's 5 different books in the library with that same name. Now you have a problem. Oftentimes you need a unique identifier to be able to properly find what you're looking for. So there's a couple different types of keys, and this can be a little bit intimidating, but really what's important is that you get the gist, and then you can easily look up a lot more details later, okay? I really can't remember the last time that I talked about composite keys to someone, although things like surrogate keys, foreign keys, those have been useful to a degree, at least as a way of referring to an idea. So a primary key, there's likely some different definitions for this. There's also, if you're in the database world with SQL Server at all, there can be some confusion about the difference between a primary key and a clustered index, because the two are related, but they're different. But as far as I'm aware, a primary key is a unique identifier for a row, and it's the canonical identifier for that row, because you may have multiple unique identifiers in a system. To give you an example, maybe you have at your office in the accounting system or the time entry system, you've got employee number and employee name. And those may both be valid candidate keys for how do we uniquely identify this person, assuming that no one has duplicate names. There's not 2 John Smiths, so you're using middle names or something like that. But the primary key is a unique identifier that from a design standpoint, you've said this is the way that we prefer to uniquely identify this row. And so in the case of an accounting system, you've probably said employee number is a safer key to use because there's no risk of duplicates. And we're going to use that. So that's a primary key. And from a database theory perspective, database design perspective, maybe more of the physical aspect, in relational systems like SQL, designating a primary key has performance and data storage impacts. And we're not going to go into those today, but just be aware that when it comes to Power BI, that's less relevant. With Power BI and Power Pivot, when you're modeling your data, you do not specify for a table what is the primary key. Instead, it's going to be relevant for the relationships that you make. But again, you never specify it like you would with SQL Server. Next is a composite key, and this is simply just a key that's made out of multiple columns. That's all there is to it. It's a multi-column key. That's all you need to know. And this is going to be relevant later for Power BI because Power BI doesn't quite like composite keys. Next are natural keys. So these are keys based on the natural data. And the flip side of that coin is a surrogate key, which is one that's arbitrarily assigned, usually a number. So going back to our example about primary keys and employee number and employee name, a natural key would be something based on employee name. Even if you have to add something to deal with duplicates, that would be more of a natural key because that relates to the system, it relates to the information about the world, it makes sense, it has some meaning, right? So if my email at work is eMeidinger, my username is eMeidinger, and if you think about it, that's a natural key if there's a user database somewhere, because that key by itself has meaning of some sort. Whereas employee number, if I'm employee number 12345, that's a surrogate key because that has no meaning whatsoever. It's completely arbitrary. And you run into this a lot whenever you deal with data warehousing because you may have data from different line of business systems, and they have different natural keys for each of those systems. And so you have to come up with a surrogate key and assign that to each of those data sources to say, okay, in this system, he's E. Meidinger, but in this system, he's Meidinger E. But in both cases, we're just going to refer to him as employee 1, 2, 3, 4, 5. Finally, there's foreign keys. And this is basically just a reference to the primary key of another table. This is just a way of relating data from one table to another. And this is going to be important whenever we talk about joins, when we talk about cardinality. In the database world, in relational databases, you can apply something called a foreign key constraint. And this is important because it can constrain, I'll give you an example. It's kind of goofy to use the state and city example, but it's the quickest one to my mind. Let's say for whatever reason, we were deleting a state. Maybe this was for SimCity or some game where we had these made up entries. Well, we wouldn't want to delete the state without being able to delete all of the cities that are related. And so you might set up something called a foreign key constraint to make sure that that doesn't happen. So there's ways that the relational database engine can take advantage of this. Power BI is able to read that information when you're reading from a relational database, but in terms of in Power BI itself, you set up certain relations, but there's not constraints in the same sense. So these are the different types of keys. And let's just take a quick look at some examples, just so we have an idea. So primary key, like I said, username, employee name, driver's license ID, those are all good examples. Composite key, city and state, make and model. You may also have something for a bridge table or an associative table, which is a table that is describes a many-to-many relationship, which we'll talk about when we get to cardinality. But basically, let's say the movie theater keeps track of every time I buy a ticket, right? So the entries for sales may have a customer number as a theoretical example, and may have a movie theater number. And you may have a composite key for a table for all those sales that uses both of those IDs. A natural key, again, employee name, customer name, state name. Anytime you have name, there's a good chance it's a natural key. Whereas surrogate keys, these are arbitrarily assigned, so employee number, social security number, anything that's a number, there's a good chance that this was arbitrarily set. And foreign key, anything can be a foreign key because it's just the primary key, but in a different table. So what does this have to do with Power BI? Why do we care? Well, if you don't understand keys, the rest of this talk is going to be gibberish. That's the first thing. That's the first starting point. Power BI, like I said, doesn't require primary keys on tables. You never specify that. You just specify the relationships, and it's implied that, okay, this is a primary key here, there's a foreign key here, but it doesn't even always have to be like that. But just something to be aware of. It does enforce uniqueness constraints on joins, and we'll talk about that when we get to cardinality. So some keys won't work if your primary key, air quotes, isn't unique for at least the one of the sides. But again, that's defined in the relationship level. There's nothing like in SQL Server where you say this column is a primary key, this is going to impact performance. Power BI does not support composite keys, at least not directly. There's no way in Power BI to do a direct join on multiple columns. So instead what you have to do is cheat. You have to fake it. And this is something that was really frustrating for me, and it makes sense from a performance standpoint with the way it's architected. But for me, it was kind of frustrating realizing that I had to create a calculated column. So you literally, what you have to do is, let's say we go back for a second and, oh, sorry. We can't go back because we haven't gotten to the proper, oh, here we go, yeah. So our composite key for city and state as an example, you can't join on city and on state like you would with SQL. It's just like a VLOOKUP where you have to have one column. And so what you have to do, just like a VLOOKUP, is you have to concatenate city and state together, maybe putting in a dash or make and model or whatever, and then do a join on that. So it can be kind of cumbersome and kind of a pain. Power BI, like I said, can take advantage of those foreign key relationships. If you were to run a trace or extended events session on the database, whenever you have Power BI hooked up, you'll see that it's reading all that foreign key information. And I believe, I don't know this for sure, but I'm pretty confident that it uses that to make guesses whenever you're joining your tables. Because if you create a project in Power BI, if you create a model and you bring in tables, oftentimes those tables will already have joins created by Power BI. Now, sometimes it's just going on date. I mean, it's going off of the name. I've seen it where I've just entered data and it says, oh, this has stayed and this has stayed, they must be joined. But I'm pretty confident based on what I see doing behind the scenes that it's able to read and access that foreign key information. And then the last thing, for any of you who are coming from a SQL background, there is no such thing as a clustered index as you understand it in Power BI. In fact, the sorting is arbitrary for the data. So in the SQL world, if you're not familiar, the clustered index is usually the primary key, and it basically says, here's the way we're going to order the data for better performance. And usually that's specified by whoever's designing the database. Whereas in this case, the DAX engine, the Vertipack engine, decides the order for doing the sort. And so again, nowhere do you really specify this is a primary key, this is a clustered index. Those concepts aren't too relevant. You're just worried about relationships. So the next thing is joins. What are joins? I'm pretty confident that almost all of you know what those are, but just to be clear, because again, we're starting from the ground up. A join is when we associate two tables via primary key and the related foreign key. Anytime that you want to combine information from two tables, you're doing a join. If you've done a VLOOKUP, that's essentially a join. If you've written SQL before and you've written the word join, you've done a join. So there's a good chance you already know about this, but just wanted to cover the terminology. So the next thing, and this is a little bit more interesting, is normal form. So normal form is an academic description of how tightly the data relates to the key. There's different levels of normal form. We're going to go through them today. We're not going to go in too much detail, but the concept of normalization versus denormalization is very, very important for how you lay out your data and how you access it. It can have dramatic impacts on the performance of your reports. So I want to give you an analogy. Let's say that we, instead of being a database engine, we're just regular people writing out information. Like let's say we worked at the government office and we want to keep track of information about the cities and states within our beautiful state or a beautiful country. And the thing I want you to think about is, what if paper was expensive? What if ink was expensive? Well, if that was the case, then you would want to minimize how many times you have to, how much repeated values you have of the same exact value, and you'd want to avoid having to make multiple changes. And let me explain. So take a look below. This is an example of a potential table. And I've underlined city and state because that's our composite key. And we've got two pieces of information here. We've got state bird and we've got city population. Now, if ink were to be expensive and we were writing this out by hand, if paper was expensive, we would be concerned about the way this table is structured, because if we look at the state bird, which in Pennsylvania is the ruffed grouse, and nobody ever knows it, and the only time I ever heard about it was in a kid's book I read in like middle school, but we have the ruffed grouse. Let's say that our state legislature said, you know what, we're gonna have it so the turkey is our state bird. We're gonna change it. Well, for each and every city that was in my table, I would have to make a change. Well, if ink is expensive, if erasers are expensive, that's a lot of work. Whereas if I were to break this out and I had two tables, I had one for state information and one for city information, then I'd only have to write out ruffed grouse or turkey once, and I'd only have to change it once. So that's the idea with normal form. So the data we're looking at isn't quite normalized. And so whenever we have to write stuff out, oftentimes we have to repeat values. Whenever we make changes, oftentimes we have to change in multiple places. And even worse, in certain systems, there's a risk of unreliability, because if I were to make these changes city by city, and then I get interrupted, maybe there's free donuts in the office. Well, now I might have a situation where Pittsburgh says the state bird is ruffed grouse, but Philadelphia says the state bird is turkey. So there's problems that you run into whenever certain things are expensive or when you're making changes. Now, obviously, no one's writing out all this stuff, but paper is an analogy for a hard disk. And ink is an analogy for the speed of that hard disk. How efficient is it to make changes on disk? Well, the world's changed a bit, and we have hard drives that are more than a gigabyte. We have databases that are easily more than 100 gigabytes. And so we've got situations where normal form doesn't always make sense, and we'll talk about that. But let's talk about some of the different levels of normal form. I don't want you to memorize these. I just want you to get a gut level understanding, okay? So first normal form. In my mind, the way I remember it is if it fits in a table, you're done. for the most part, if it fits in a table, you're pretty much done. So if you think about Excel, just because you can put it in an Excel sheet does not mean it fits in a table. So if you've got some headers, just for decoration, not regular headers, if you've got blank spaces and it's assumed that they're supposed to fill down, if your data doesn't fit into here's the columns, here's the column headers, every field, every cell has values, it may not be in first normal form. But generally speaking, if it fits in a table as you understand it, it's probably first normal form. If you can fit it in SQL, it's almost certainly first normal form. So when it says no repeated groups, that means that if we were to go back to our ruffed grouse example, if we had rough grouse just at the top the once and then it was blank below and it was implied, that would not be first normal form. So this example here is in first normal form at the very least. So second normal form, one other thing I want to mention with first normal form, no comma separated values. If you're trying to fit multiple values into one cell, it's not first normal form, okay? Second normal form is everything that relates to only part of the key needs to go in its own table. So if you've got a composite key, everything in that row should be relating to the entire key. That key should be a unique identifier. And then third normal form is everything that can go into its own table does. So that means that if you have any values that are repeated but don't have a key to directly relate to, they need to go into their own table. Again, I don't want you to memorize all this. A lot of this is theoretical that you're not going to know, but I want you to get a feeling for this progression. So let's take a look again at that data that we had. So what level normal form is this? So we can look at it and we can say that it's at the very least first normal form because we don't have any missing values. We don't have any repeated values or we don't have any values where it's comma separated. We just have our header, we just have our values. We don't have like just random stuff strewn on the Excel sheet or something like that. Like when people use Excel more like a canvas than a data structure, it's probably not first normal form. If we look at this, it's not in second normal form, and I'll tell you why. Let me see if I can underline things. Give me 1 second here. So if, okay, so if we take a look at this information about state, ruffed grouse relates just to state. And so second normal form says, hey, this doesn't depend on the entire key, so this needs to go into its own table. And so what it would mean is that we would end up having a state table for just state-related information. So it's not in second normal form. And then if we had some information here, maybe relating to business, right? Maybe each city has the most popular business or something like that, that is tied to just this composite key and not a single portion, but really could be brought into its own table. Like we would create a business table or something like that. That's third normal form. Again, you really, really do not need to know all the distinctions. You just need to understand a bit of the spectrum. And so as things can get more normalized, they can also get denormalized or less normalized. So normal form is optimized for saving paper and ink, metaphorically. It's optimized for saving hard drive space and the number of writes that you have to make. Denormalization, conversely, is optimized for reads, because a lot of times you'll have a big table, but only a few rows that you want. And what you're able to do is just grab those rows without having to do any joins or without having to do as many joins. And that can be more performant for your reads. Remember, when you're reading information from a relational database system, the more joins you have to do, the slower it is. And going back to something I said before, if you've ever taken a multi-table query or multi-table information and dumped it to a flat file, you've denormalized that data. Congratulations, you've denormalized something. So anytime you're dealing with a single flat file and it's relating to more than a single table, that's denormalized data. Denormalized data, like I said, is preferred oftentimes for analytical reporting because most of the writes are for a data warehouse system are being done at night all at once. And so it's okay to have writes be a little bit slower or to take a little bit more information so that our reads are much, much faster and we have to do fewer joins, because when you have complex reporting, those joins and the slowness with the reads can be a real problem. Okay, so we talked about normal form. Coming back to our key question of all this, what does this have to do with Power BI? So first thing, like I keep saying, you do not need to memorize these levels. Third normal form is bad for Power BI because it's overkill. And you'll find that a lot of ERP systems aren't even in third normal form. They're in, well, this kind of makes sense to me, normal form. Generally, I've seen with a lot of systems, instead of moving every single possible thing out to its own table, it's got tables for things that are separate entities, and then you may have a little bit of denormalization for some of your transaction tables where you want to have a historical copy of the information, that sort of thing. But third normal form doesn't work well for Power BI when you're modeling your data in that with DAX because joins are expensive. But going all the way to the other end is bad too. You don't want wide tables when you're dealing with Power BI because we can't go into the exact specifics here. If you want to learn more, check out the same presentation I did for this group a few months ago about an introduction to DAX, where I talk about how the engine works. But the part you need to understand is the DAX engine, the Vertipack engine, uses run length encoding to do compression, among other things. And the longer the runs, the better the compression. As a result, it sorts the data in ways to make the longest runs possible. The more columns you have, the worse the compression, because those last columns aren't going to be organized the way that you want. It's kind of like whenever your hard drive gets fragmented. If you have a lot of columns, those last ones to be sorted, as determined by the DAX engine, are going to be fragmented, so they're going to have very short runs, so they're not going to compress well. Power BI is optimized for deep, skinny tables with a minimum number of joins. It's good for a few joins for doing filtering, don't get me wrong, but it's really designed for, okay, you can have millions and millions of rows, but try to just have maybe like 6 columns for your main table, you know, something like that. It's also optimized on a related sense for SCAR, I can't talk, it's optimized for star schema. And we'll talk a little bit about that at the end, but basically it relates to what we talked about. It's the idea of, okay, we don't want third normal form, that's overkill. We just want some of these really big transactional detail tables and then a few tables related to that for more of our reference information. So that's normal form. It's really important to understand the general concept because it has a huge effect on your performance, but you don't need to memorize every single little thing. So the next thing is granularity. So we're going to talk about grain. We're going to talk about the level of detail. So granularity or grain is basically how fine of a level of detail are we talking about. So let's look at some data. Again, it's the same data as before, but let's look at some data and think about this. The key question when you're dealing with granularity is when you look at a row, can you say, what does this row represent? And something I like to think about is if you ever took chemistry or any other kind of science, probably more physics really, and you had to deal with multiplying different units of measure, right? So if you have foot times pounds, that's foot pounds. Or if you've got velocity, that's meters per second, meters divided by second, whatever. So the granularity is all the different keys kind of multiply together. That's one way I like to think about it. And the more keys you have, the finer the granularity. It's not always true, but it's a nice rule of thumb. Here, it's kind of confusing what a row represents. Because if we look at the keys, we see city and state. And so really, this row represents a city. If we think about it, that's the level of granularity. And so if we were to think about as a hierarchy, the coarsest level of granularity we could have for this kind of data would be planet or country. And then there's state, city, and if we were going even smaller, we could say individual person, right? So the more detailed and the finer the information, the finer the granularity. So you may ask me, what does this have to do with Power BI? So granularity is really important for understanding how to structure your relationships, how they're going to be structured. They're going to help you with understanding cardinality on an intuitive level, which we're talking about next. Generally speaking, as a rule of thumb, it's not always true, but generally you're going to put your aggregates on your fine granularity tables, like a sales table for all your sales order line items, and you're going to put your filters on your coarse granularity tables, your customer table, your location table, that kind of stuff. There are exceptions, but something you want to avoid is if we go back, you want to avoid getting your granularities mixed up, and you want to avoid having your aggregate information at the wrong level of granularity. So to give you a quick example, I don't have it here, but let's say I added a state population column here, and then I tried to do a sum. Well, just like I talked about at the beginning, I would get duplicate values. I would get values that didn't make sense because I have state granular information on a city granular table. Now, if this was in second normal form, that would be impossible because I would be required to take that state level information and move it into its own table. So that's one of the reasons why normal form is relevant. But again, you don't need to know a ton about granularity, but understanding it on an intuitive level is so helpful for working with your data and laying it out in Power BI. Because for me, I often look at, okay, what's my detail information and what are the reference tables that I need to join to it? It's also important, everything I've talked about here on this page is an analogy for what we're going to talk about in just a little bit about facts versus dimensions, and again, star schema. So granularity is intertwined with something called cardinality. And cardinality is way too fancy of a term. It's a mathematical term. It relates to the size of sets of numbers to each other and that sort of thing, or potentially the size of different sets in relation to each other. It comes up in math when you're dealing with different sizes of infinity and you're talking about, okay, how big are all of the integers versus all of the fractions? Because it turns out that the number of fractions is, I believe, countably infinite, but decimal places is uncountably infinite. It's been a while. You don't need to know any of that. What you need to know is cardinality is basically asking how many rows from one table correspond directly to the rows in another. And so you can see here, there's three options when you're dealing with Power BI. There's a many-to-one relationship, a one-to-one, and a one-to-many. I can tell you that in my 5 years of working with databases, I have almost never, ever had to deal with a one-to-one relationship. Because why wouldn't you just have that in one big table? There's very rare circumstances. One potential scenario is if you're dealing with SQL Server, you may decide that you have some information you want to vertically partition out and some bigger, slower information that you normally don't want to mess with querying, but occasionally you do a join or something like that. But generally, you're going to be dealing with a one-to-many relationship. What's a one-to-many relationship? Well, think about it. Every one state has many cities in it. Every one city has many people living in it. So generally, it's a hierarchical relationship. There's also something called many-to-many relationships. So going back to the example about movie theaters, and again, I know that a real movie theater is not going to have, per se, a customer ID, although they might have my credit card information, who knows. There's a many-to-many relationship between me and the theaters because I go to many different movie theaters and those theaters have many different customers. And so a lot of times you're going to have a bridge table in between that has both those factors as that composite key to join that information. So what does this have to do with Power BI? Well, your filters are generally going to be going from the one side to the many side. So if you've got a table full of orders, sales orders, or an example with movie theater sales, then the one side is going to be the customer. The one side is going to be the location for, say, the theater or the business or whatever. And if you understand how those relationships work intuitively, it's really easy to arrange your data and work with it. The next thing is Power BI does not implicitly support many-to-many relationships. If you were to look at that picture that I had, it wasn't an option there. Instead, you either have to do some gymnastics with your formulas and say, okay, well, if this other table is filtered, then I want to filter this stuff. But more recently, they've added support for bidirectional filtering, where you can say that, okay, I'm going to filter on customer, which is going to filter the sales data. And because I have a bidirectional filter, it's going to filter back up to location and that sort of thing. Now, we don't have time today to go into detail about that, but Marco Russo at SQLBI.com has a really, really good article explaining the way that you used to have to do it and the way that you can do it now. And it can be a little bit confusing, so definitely take a look at that. Additionally, bad data and bad cardinality can prevent joins because your keys, at least on the one side, have to be unique. And I've run into this issue myself where I've been artificially trying to create a key for some reporting, and I had some duplicates. The example was I was trying to pull employee number or employee username from some timesheet information we had, but the primary key from that information, the employee code, didn't have anything to match to. So instead of trying to just manually, instead of having to have a reference table that ties it together and have to manually add it, what I tried to do is I tried to pull the first part of the email out, right? So I said, okay, well, my employee code is EJM, but in the system, my email is emeitinger@alllinestech.com. Well, I can just grab that and use that to connect to a different system. Well, the problem was some entries didn't have emails. In addition to that, we also had accounts for certain groups, and so certain people's emails were in there twice. And so I couldn't do a join initially and was very confused because my data didn't reflect the cardinality that I was trying to set up. So that's cardinality. It's a big fancy word for one-to-many relationships, one-to-one relationships, many-to-many relationships. That's all that it is. Okay, so the last kind of piece that we're going to talk about today, and we're going to go into some more detail about some of the nitty-gritty with this, is OLTP versus OLAP. These are four-letter acronyms, and they're a giant pain because they have this really fancy definition for a lot of people. They have this meaning for people. But for me personally, you know, I like to think about the types of systems they deal with. So I used to be intimidated. OLAP, this sounds fancy. It's not. Online transactional processing is your traditional relational database design. It's highly normalized. It's often in second or third normal form. It's optimized for those same things, for modifying individual transactions, for changing a single customer, a single order, adding a single line item, whatever. So that's the way that it's structured. If you're an ERP system, an accounting system, whatever, that's going to be OLTP. Well, like we covered, those systems and those structures are not optimized for reporting. So they came up with something called OLAP, which is online analytical processing. And basically that's that structure we talked about. It's slightly denormalized data with your fact tables, which we're going to talk about in a second, your transaction tables in the middle, surrounded by your dimensions, your reference tables. This is oftentimes star schema. There's something also called snowflake schema, which is kind of a hybrid between star schema where you have a single transaction table and a bunch of dimensions, and then more of a third normal form where those dimensions might have dimensions. So for example, we might have a location table, but it has a state table as its own dimension, whatever. And these are optimized for reading and analyzing data. It's optimized for BI. I know I've got about 5 or 6 more minutes, and then I'll be done pretty soon. We'll have a couple minutes for some questions. So when you're dealing with OLAP, you might hear about facts and dimensions. And this, when I first learned about this, made no sense to me, didn't mean anything to me. So just to give you a quick understanding, a fact table is your central transaction table. So this usually has a surrogate key. If you think about it, when you have an order, a sales order, it's often assigned an arbitrary number, right? It's just an incremental number. You are customer 12345. This is order 17294. whatever. And usually has many foreign keys to tie to those reference tables around it. It's often very detailed, so we're going to put our aggregates there. It's often very granular, and it's continually growing. This is the table that might have 1,000,000 rows. A dimension table is your reference table, and these are the things that you carry the reference information on. So this would be your state table, your customer table, your employee table. This usually has a natural key that relates to the information because it's reference information. It's not an arbitrary transaction of some sort. This is going to have coarser granularity. You might have 1,000,000 sales, but maybe only 10,000 customers. Or you might only have 50 states you sell in, or whatever. This is going to change much more slowly, and it's going to grow much more slowly. So what does this have to do with Power BI? So oftentimes, again, you're going to use dimensions for filters, you're going to use facts for aggregates, and you want to try and aim for a star schema design or something similar. Now, this isn't multidimensional for SSAS or anything like that. It's tabular mode. So you're not constrained to this structure. You don't have to use star schema or anything like that. But generally, you're going to have better performance just from the way that the engine's designed. Again, if you want to learn more, check out the presentation I did for the same group a couple months ago. It's up on YouTube about DAX, because I go into the engine a little bit in detail and talk about how that stuff works. So just a quick summary. Keys identify rows. Tables are joined on primary keys to foreign keys. Granularity helps you identify the relationship. You know, if you've got state and you've got city, it's going to be a one-to-many relationship from state to city. Cardinality helps organize those relationships, and you want to aim for something called star schema design. You can look it up on Wikipedia, with a central transactional fact table surrounded by these dimension tables. So that's my entire presentation. I appreciate everyone attending. Does anyone have any questions?
Yes, Eugene, can you hear me?
Yep.
All right. Yeah, there's a couple questions out there. Great presentation.
Thank you.
First one is, this started in the very beginning. He
Sure.
says, can the connection to the SQL database in Power BI be parameterized in a manner that would allow a slicer of other control to allow the user to select a target server, target database to switch the presentation to with the different database with a common schema but different data?
Right. So that's, I believe so, but that's something I'll have to get back to you about, because there was actually a past presentation that I just started watching by Chris Webb, where I think he was going to talk about how to do that. If you did want to do something like that, you're going to be working in Power Query. Power Query does definitely support parameterization. I know that for certain, and you can definitely parameterize your connections so that you talk to a different database. That all works just fine. What I don't know 100% is, can you take what was chosen by the user from the UI front end and fit that into that parameter? I believe that you can, and I know Chris Webb has a presentation from past, I want to say 2015, about creating a reporting solution in Excel, where I just started watching it, but I think he explains how to do that. But I'm more than happy to circle back with an answer on that. But I know 80% of that you can do for sure. It's just the UI connection back to Power Query or the M language that I'm not sure about.
Okay, the next one is, can we get a copy of your presentation?
Absolutely. So one, I will put it up, you see my website there, I'm going to put it up today by the end of the day on my blog. But additionally, I'll get a copy to Thomas in the group, and whenever the video goes up, they'll have a link to the slides as well, right?
Yes, yes, you can. So during the presentation, you were talking about denormalization. This guy says, can you change in your slide demoralization to denormalization on line 2?
It's a funny typo. I do appreciate that. I apologize to everyone for the typos on this. I've been working on this all week, and there's a couple that slipped in. So yes, I'd be more than happy to fix that, and I will fix it before I post the slides, so no one's confused. Thank you.
So you were talking about the joins, and this guy asked, how can you be optimized for star schema, which is rife with joins, and also say Power BI is optimized for few joins,
Sure.
and joins
Yeah.
are expensive.
Yeah, no, I'm happy to answer that. And that is a good question because when you do have star schema, you could easily have 10 different dimensions around your transaction table, right? Um, the the way to think about that is if you do it right, you're treating ideally Power Pivot and Power BI as more of an analytical engine, which means that you're not pulling in a lot of textual information. It's more about aggregates and filtering, right? So if you're pulling in every single thing, then you're forced to pull on all that information, and it's not ideal. But if you're just doing aggregates and filtering, the DAX engine is optimized very highly for doing aggregates. It's okay for basically saying, all right, you filtered on these two states. I'm going to grab the internal ID that was used by the engine and filter on that in DAX or in the central table. And oftentimes, even when you're dealing with a pivot table, oftentimes you're only hopefully doing an implicit filter or an explicit filter on just a couple different values and a couple different tables. And so it only has to apply filters and it only has to do those joins effectively on those things that you care about. Because that's the thing is whenever you're pulling in the information, like let's say I have total sales, right? I'm the CEO of this movie theater company and I just want to see all the sales in the state of Pennsylvania, right? As a result, I only have to apply that filter and apply that join on the location table to the central table. I don't have to apply it to customer. I don't have to apply it to store potentially or any of these other things. And I talk about more in the DAX presentation I did, but the data is stored as columns. And so if you're just filtering on state and you just want a total sales for maybe the current year, for example, then all it needs to do is join on just some basic information from state and date and just read the columns from the central table. So that is a good paradox that you bring up, but generally if you can keep your star schema to just some simple filtering and a minimal number of filters, the DAX engine doesn't have to do all those joins. It only actually has to work with the stuff that you care about. Whereas if you were doing a SQL query and you're implicitly doing all that join information to get all the data, it's going to be really painful.
Yeah, I think what this guy was too referring to is when you were comparing the normalized database to a
Sure.
star schema, and it is tough. If you read the Kimball books, they'll break that out by data marts, and to make the star schema smaller is just more efficient. But it does happen, and I kind of understand this guy. Here's the
Yeah.
last question though.
Yep.
He says, "I've I've got 20 plus columns in one table, so it is better to leave as it is or remove some of the calculated column with measures." So I think he's saying he's got it
Yeah.
all in one table. Is it better to leave as is or do I remove it and put the calculations in Power BI?
Sure. So definitely check out the DAX presentation I did for this group because I go into a lot of detail about compression and calculated columns and all that. But what it's going to depend on is how correlated those values are. So to give you an example, if I've got state and I've got city, city is really strongly correlated to state because most of the Pittsburghs are going to be in Pennsylvania. And so if I sort by state and then sort by city, I'm going to have a long run. Well, I wouldn't have a long run of, there's only one Pittsburgh, but if I was dealing with a finer level of granularity, there'd be a bunch of Pittsburghs. Like if I had a table of stores or something like that. The thing that you need to figure out is how correlated is your data. So let's, take that same example. If we talked about population, the population in a city is almost uniquely identified with the city itself, right? Because there's such a wide range of values, you're not going to have a lot of repeated values. So if you have a lot of repeated values and a lot of correlation between your columns, then it's able to compress it very strongly. But if you've got uncorrelated data or unique data, like social security number is unique, goods are unique, that sort of thing, then you may be running into compression problems. Another thing is that I forget who, I want to say, I think Marco Russo and Alberto Ferrari have tools where if you're at least in SSAS, I'm pretty sure they have tools where you can see how much memory the stuff is taking up and how well it's compressing. I forget exactly off the top of my head. I'll try and get some notes. But there are tools out there that can help you identify how well your data is compressing. But the quick answer is Multiple columns are useful, or they're fine if the data is well correlated. Making a calculated column won't make a difference because that data is materialized, and so it's just as if you imported a regular column. All right, so
All
final
right.
question. Thank you
Yeah,
guys. Go ahead.
that's it. Thanks a lot, Gene. Again, this session is going to be recorded. If you go back to our website, it'll be a link that'll bring you to our YouTube channel. So any session in the last probably 3 years on the Excel BIVC is recorded and saved to our YouTube channel. So thank you again, Gene. I look forward to you presenting again. And
Awesome.
that's the end of this session. Thank you, guys.